Our subject for this first semester of the new normal school year 2020-2021 is General Mathematics. And this subject is composed of three different branches of mathematics. We have Advanced Algebra, Business Mathematics, and Logic. Advanced Algebra is different from that of the Elementary Algebra and Intermediate Algebra. Elementary algebra deals with the fundamental operations on integers and fractions, and it also utilizes simple polynomials. Intermediate algebra utilizes the variables x and y to represent simple and advanced polynomials, expressions, and equations. And in this intermediate algebra, minimal graphing of the equation on the Cartesian plane is evident. In advanced algebra, every time that we are going to discuss a function, we are to graph that particular function on the Cartesian plane. Business mathematics is also known as the mathematics of investment. It deals with the management of investment in order to maximize the profits and minimize the losses of that particular investment. And it is talking about the different investment that a certain person is going to engage. And logic is talking about the science of valid or correct reasoning. By the way, I am Samsudin and Abdullah, and I am your teacher for this particular subject for the first semester of this school year 2020-2021. This is our major topic for this video presentation, and this is talking about functions and relations as represented by different forms of representations. But prior to that, I am going to present to you the objectives of this PowerPoint presentation converted into video presentation. At the end of this particular video presentation, the students are expected to determine whether or not an ordered pair or an arrow diagram represents a function. Second, tell whether a table of values or an equation is a function or a relation. 3. Use vertical line test to tell whether a graph is a function or a mere relation. We are going to represent functions and relations through ordered pairs. So when we say ordered pairs, we have the x value and we have the y value. The first element in the ordered pair is the abscissa. The second element in the ordered pair is the ordinate. And if you're going to generalize the calling of these values, coordinates. So another term for abscissa is x-coordinate. Another term for ordinate is y-coordinate. Or another term for the ordinate is the image. No, the image of the or the values of y. So tell whether or not each of the following relations describes a function. Take note of the direction, right function or not function. So this is the term that you are going to write in your answer. Okay, number 1. The first thing that you're going to do in order to identify whether or not this set of ordered pairs is a function is the first elements. The first elements are 1, 3, 4, and 5. So we have 4 different first elements. It means that there is no repetition of the first element or the abscissa. And this is a function. Now, if it is a function, additional tasks will be given to you to identify whether that function is one-to-one or onto. No? Okay. Now, we are going to determine whether this function is one-to-one. So we are going to observe the y values. We have 2, 5, you have 6, you have 5. It means that there is one value in y that is mapped with two different values in x. This is many to 1. Why many? Because you have 3 and you have 5 with only one image, which is 5. So this is not 1 to 1. But you can consider this as onto. Number 2. The first and the second ordered pairs have the same abscissa. Therefore, this is not a function because our abscissas must be unique from each other. They should be different from each other. So this is many to many. Why many? Because two different abscissas have one image and one abscissa is paired with two different ordinates. That is why many to many. And this is not a function. Okay? Relation has four types. We have one-to-one, we have many-to-one, and these two are functions. The third is one-to-many and many-to-many, and these are relations or mere relations, or they are not functions. We will proceed with number 3. The abscissas are 1, 3, 5, and 7, and this is a function. We are going to determine whether this is a one-to-one or not. So we have 2, 4, 6, and 8. And this is 1 to 1. We will proceed with number 4. You have negative 1, 2, and negative 1. This is not a function because our relation is 1 to many. Why 1 to many? Because negative 1 has two images, has two different images. You have negative 1 and 0. And this is 1 to many, and 1 to many is not a function. Okay, so if it is not a function, we will not identify whether it is 1 to 1 because when we say relation, it is automatically not 1 to 1. It is automatically will not apply the concept of 1 to 1. Number 5, we have negative 1, 0, 2, and 3. Four ordered pairs have distinct abscissas, and this is a function. We are going to identify whether this function is 1 to 1 or not. So negative 1, 0, 2, and 3. And this is 1 to 1. Number 6. Our abscissas are negative 2, negative 2. And this is no longer a function because this is 1 to many. No, 1 to many because one abscissa has two different images. We have also here 2 and 2 with two different images. So this is not function. Number 7. Okay, we have 1, 2, 3, 4. And this is a function. We're going to identify whether this is 1 to 1 or not. 2, 3, 4, 5. Four different images. Therefore, this is 1 to 1. We will proceed with number 8. 0, 0. This is not a function anymore because the four ordered pairs have only one abscissa and this abscissa has four different images. You have 1, 2, 3, and 5, and this is not a function, of course. And number 9, we have the abscissas are 4, 5, 6, 7. So the abscissas are distinct from each other and this is a function. We are going to identify whether it is 1 to 1 or not. 5, 5. This is not 1 to 1 because two different abscissas has only one image. So this is not 1 to 1. Number 10. The abscissas are 5, 6, 5, 8, and 9. This is not function because 5 is mapped with two different values in the y. We have 5 and 7. So this is not a function. So we will proceed with functions and relations represented by arrow diagrams. Determine whether or not its arrow diagram represents a function, right function, or relation. Take note, if the instruction is right function or relation, do not write function or not function because you are not following the instruction. Instruction is a part of the test or assignment. Number 1, this is one to many and this is not a function because one element of the domain is having 5 different images in the range. Number 2 is a function. Why function? Because this is many to 1 and this is onto. Why onto? Because all of the elements in the range have the mapping in the domain. So this is a many to 1 onto function. We will proceed with number 3. This is a function. Is it 1 to 1? Yes. This is 1 to 1 function, but it is not onto because negative 3 does not have the corresponding element in the domain. So this is 1 to 1 function, but not onto. So we will proceed with number 4. This is 1 to 1 and it is also onto. It's very simple for you to identify whether a function is 1 to 1 because every element in the domain is mapped with a unique element in the range, and if all of the elements in the range have the corresponding elements in the domain, that is onto. So therefore, this is 1 to 1 and this is also onto function. We will proceed with number 5. This is many to 1. 4 different abscissas have only one image and this is many to 1 function. And it is also onto because there is no other element of the range which is not mapped with an element in the domain. So this is many to 1 onto function. This is function. We are going to observe if all of the elements of the domain have corresponding elements in the range. There is one element in the domain which is not mapped with any element in the range. If that is the case, this is no longer a function. And this is a relation because the concept of function is that all elements in the domain must have the corresponding images in the range. And another concept is that each element in the domain should be uniquely paired with one element in the range. Since that negative 6 is not mapped with any element in the range, this is a relation. We will proceed with number 7. This is many to 1. Why many? Because you have negative 2 and negative 5 have only one image and this is 7. And this is a function and this is also onto. Why onto? Because the 3 images, the 3 values of the y have the corresponding elements in the domain. This is a function. And this is a very perfect example of 1 to 1 or onto. So this is a function and this is 1 to 1. And this is also onto. It's very simple for you to identify whether it is onto if all of the elements in the range have the corresponding elements in the domain. It is onto already. We will proceed with number 9. There are 4 elements in the domain and one of these elements is not paired with any element in the range and this is not a function. This is a relation. And number 10 is also a relation because you have one element in the domain which is not mapped with any element in the range. And this is a relation. We will proceed with functions and relations represented by tables of values. Determine whether or not each of the following tables of values is a function, right function, or mere relation. Take note, our instruction is to write function or a mere relation. Always follow the instruction carefully. Number 1, this is our table. Our x values are 0, 1, 2, 3, 4, 5. And our abscissas are unique from each other. And this is a function. Is it one-to-one? Yes, it is one-to-one because the images are different from each other. And this is also onto. Number 2, our table of values is this one. Our x values are 9, 4, 0, 4. Take note 4 has two images. Therefore, this is a mere relation. And so with 9, we have two images. We have the 3 and negative 3. So we will proceed with number 3. The table of values is this one. Our x values are negative 2, 4, 2, negative 2. Now, you have negative 2 here. You're going to observe if this negative 2 has different images. If that will be the case, it is no longer a function and this is a mere relation. We will proceed with number 4. Abscissas are negative 5, 4, 3, 2, negative 5. Now, take note, our image is just only the same. It means that this point is the same with this point. And this is a function. And this is one-to-one. And this is also onto. 5. Our x values are 81, 16, 1, 0, 1. Now, take note, 1 has two different images. And so with 16, has two different images. 81 has two different ordinates. Therefore, this is not a function and it is a mere relation. Number 6. The table is this one, negative 5, 4, 2, negative 2, 5, 6, negative 5. So, you have negative 5 is repeated in the last ordered pair. But take note, you are going to observe the image. If this negative 5 has only one image, which is 7, meaning this point is same with this point. Therefore, this is a function. This is also one-to-one and onto. Now, we will proceed with number 7. The table is this one. Abscissas are negative 2, negative 1, 0, 1, and 2. And this is a function. And this is one-to-one. And this is also onto. Number 8. Okay, the table of values is like this one. The abscissas are negative 2, negative 1, 0, 1, and 2. And this is a function because the abscissas are distinct from each other. No two ordered pairs have the same first element and that is a function. And this is one-to-one. Number 9, the values of x, negative 1, 3. You have 2, negative 4, 3. Now take note, 3 has two different images. Therefore, this is a mere relation. This is a mere relation because not two ordered pairs should have the same first element. It is no longer a function and it is a mere relation. Because when you say function, it is a relation in which no two ordered pairs have the same first element. Okay, the last number for this functions and relations represented by table of values is this one. The table of values is our x values are 2, negative 1, 4, 0, 3, and 2. 2, and you have there 2. Meaning the first ordered pair and the last ordered pair have different ordinates. And that is negative 1 and 14. And this is a mere relation. We will proceed with functions and relations represented by equations. Which of the following equations are functions? Which are not? Right, function, or not function. Take note, the instruction is function or not function. Number 1, the first thing that you're going to do in order to identify whether a certain equation is a function or not function is only the exponent of y. If the exponent of y is odd, when you say odd, starting from 1, going to 3, 5, 7, etc., and that is a function. Now, we are going to identify whether it is one-to-one. You are going to observe the exponent of x. If the exponent of x is odd, it is one-to-one. Therefore, this is a function and this is one-to-one. Number 2, observe the exponent of y. to identify whether it is a function or not. The exponent of y is 1, therefore this is a function. Identify whether this function is 1-to-1 or not. If the exponent of x is even, this is not 1-to-1, but this is a function. Number 3, observe the exponent of y. The exponent of y is 1. And you're going to observe you have only one sign here, positive only. And therefore, this is a function. And this type of function is square root function. And this is half of the parabola opening to the right. This is a function. And this is 1-to-1. Because the exponent of x here is 1. And that is add. We will proceed with number 4. Y is equal to positive and negative square root of 5x minus 3. Now, the exponent of y here is 1. It is a function or not? This is not a function because positive and negative signifies we have the exponent 2 there. Positive and negative signifies that the exponent of y is 2. And therefore, this is not a function. Why not function? Because in every one value of x, there exists two different values of y. And the graph of this one is a parabola opening to the right. Now, if I am going to remove positive here and we have only negative there, this is a function because that is half of the parabola opening to the right. And that is square root function. Like this one. If I'm going to put positive and negative here, it is no longer a function. I'm going to remove the negative sign and it remains only the positive. It is already a function because that is just only half of the parabola opening to the right. This is not a function. And number 5, our exponent in y is 2 and this is even and this is not a function. And number 6, the exponent of y is 3 and this is a function. And this is not 1-to-1 because the exponent of x is 4. Number 7, the exponent of y is 5 and this is a function. But the exponent of x is 4 and this is not 1-to-1. Number 8, the exponent of y is 6 and this is not a function. So if it is not a function, we will not identify whether that relation is 1-to-1 or not because when we say relation, it is automatically not 1-to-1. Number 9, the exponent of y is 7 and this is odd and this is a function. But this is not 1-to-1 because the exponent of x is 2. Number 10, the exponent of y here is 5 and this is odd, therefore this is a function. But this is not 1-to-1 because the exponent of x is 4. We will proceed with the last subtopic of our lesson, which is the functions and relations represented by graphs. The direction is use the vertical line test to determine whether or not each graph represents a function. Right function or not function. By the way, what is the perfect example or concrete example of a vertical line? Because the post or the tree might not be vertical. The perfect or the concrete example of a vertical line is a person with a very good posture standing. The line being produced by a person standing is a vertical. So therefore, don't be confused with the vertical and that of the horizontal because some of the students, the instruction is use vertical line. If the graph is a parabola opening upward, they are drawing horizontal lines so that that horizontal line will intersect the graph into two different points. That is not the vertical because the instruction is use vertical line to determine whether a graph is a function or not. So don't be confused of the vertical line and that of the horizontal line. To determine whether a graph is a function or not, use only vertical line. Do not use horizontal line. The instruction is function or not function. For number 1, you are going to draw a vertical line. How are you going to draw a vertical line? Like this one. How many points of intersection? There are 2. We have and The second one, there are 2 points of intersection. Sir, there is also point of intersection here. No, our graph is this one. This is our Cartesian plane. So if the vertical line intersects the graph in more than one point, not a function. We will proceed with problem number 2. The graph is like this one. Some of the students are drawing horizontal line like this one because their aim is to intersect the graph into 2 different points. But the instruction is use vertical line test. Don't be confused with the vertical line test. Vertical line is a line being produced by your body if you are standing. This is a vertical line. Draw a vertical line here. And the point of intersection is only 1. And this is a function. This is a function because the vertical line intersects the graph at 1 point only. Now, to determine whether this function is one-to-one, that is the time that you are going to use the horizontal line test. If that horizontal line intersects the graph in more than 1 point, it is no longer one-to-one. Therefore, this is not one-to-one. We will proceed with number 3. We will draw a vertical line. Point of intersection is only 1, and this is a function. And this is one-to-one because if you're going to draw horizontal line here, you can only intersect the line in 1 point. We will proceed with number 4, drawing a vertical line. You have only 1 point of intersection. Drawing a horizontal line, you can also have 1 point of intersection. Therefore, this is a function. And this is also one-to-one. Now, here comes our graph. Okay, that is our vertical line. How many points of intersection? There are infinitely many points of intersection. So therefore, this is not a function. Take note, all lines parallel with the y-axis are not functions. They are relations. They are mere relations. They are not functions. Now, number 6, we are going to draw a vertical line. Is it a function? How many points of intersection? You have only 1. And this is a function. Is it one-to-one? We are going to draw an imaginary horizontal line. And this is not one-to-one because if you're going to draw a horizontal line, take note, horizontal line is a line parallel with the x-axis. There are 2 points of intersection. And therefore, this is not one-to-one, but this is a function. We will proceed with number 7. We are going to draw a vertical line. How many points of intersection? You have 1 and you have 2. This is not a function. How about this one? Is it a function? Yes. Because of the vertical line, you have only 1 point of intersection. Now, it is a half of the parabola opening upward. Is it one-to-one? Yes, it is one-to-one because if you're going to draw horizontal line, you have only 1 point of intersection and this is 1-to-1. We will proceed with number 9. Take note, in our graph number 9, there is a portion in which this portion of the graph is parallel with the y-axis. Therefore, do not draw your vertical line here. And do not also draw your vertical line here because you're going to draw the vertical line in the area in which you can intersect the graph into 2 or more points. So therefore, our vertical line must be here. Because if you're going to draw your vertical line in this area, you might have a wrong answer because you have only 1 point of intersection. So the points of intersection are infinite also. There are so many points of intersection and this is not a function. Last number, take note, we have 3 different functions here. We have here the half of the parabola. We have here the horizontal line with the limited domain. And we have here the half line. Half line does not have the endpoint. But if there is a closed circle here, that is ray. So that is the difference between ray and that of the half line. This is a half line because we do not have the endpoint. And if we have only one endpoint, that is a ray. Therefore, half line is a subset of a ray. Now, where are we going to draw our vertical line? You can draw your vertical line here. You can also draw your vertical line here. You can also draw your vertical line here. You cannot have a wrong answer. Because when you say open circle here, the point here is not included. If you're going to draw a vertical line here, you have only one point of intersection, and this is it. If you're going to draw a vertical line here, you can also have one point of intersection, and that is it. Because there is no point here. There is no endpoint here because open. Okay, this is a function. By the way, this graph is an example of piecewise function, and we will be having the graph of piecewise function and other basic functions in the next video presentation. This is a function. This is not one-to-one. Why? Because if you're going to draw a horizontal line here, you have so many points of intersection between this sub-function with that of the horizontal line. And this is your assignment. Letter A, copy including the instruction and answer. You're going to answer here letter A, and this is ordered pairs. You're going to identify whether this relation is a function or not. One-to-one or onto is no longer part of our assignment, and that is just only a review. So do not write one-to-one or onto, because what we are going to do here just only is to identify whether or not a relation is a function. So therefore, do not anymore write one-to-one or onto. Letter B is a relation represented by arrow diagrams. There are 12 questions here. Letter C, our relations are given by table of values. Take note, the instruction is right function or mere relation. There are 10 items here. You don't need to identify whether a function is one-to-one or onto. It's not part of the instruction. I just only included that in the explanation so that you can have the review of what is the meaning of one-to-one, one-to-many, many-to-many, and many-to-one. So letter D, which of the following are functions which are not right function or not function? So these are equations. It's very simple. You don't need to identify whether it is one-to-one or not. And the last is draw graphs. You are going to draw a vertical line or imaginary vertical line only. And you're going to determine whether this graph represents or not represent a function or a relation. Now, generalization. Function is also a relation, but relation is not a function. Function is a relation in which no two ordered pairs have the same abscissa. In other words, the abscissas must be uniquely paired with any element in the range. It must have a unique image in the range. And the set of admissible values of x is the domain. Why admissible? Because not all real numbers can be substituted to the x. There are admissible and there are not admissible. That is why we will be able to deeply understand what is the meaning of domain and range in the next lessons that we have. So range is a set of images or the values of y, the resulting values of y, after substituting the values of x. Then take note, if you're going to determine whether or not a relation or a graph is a function, you're going to use the vertical line test. Okay, because if the vertical line intersects the graph at one point only, it is a function. Then to determine whether a function is one-to-one, you're going to use the horizontal line test. If that horizontal line intersects the graph at one point only, it is one-to-one. That's all. Thank you very much for watching this particular video, and we will see each other in the next video presentation.